Okay, so here we are. Hopefully I can erase. I'll have to stay here and erase. So you can see what we got here. I'm seeing the screen a little bit. But I showed a new way of doing little synthetic division here. To do it all at once, so I don't have to keep rewriting the polynomial. So write the polynomial coefficients up here, and then do a line like this, yoink, and then straight down. What I'm going to do is synthetically divide by these four numbers. The only thing you have to hold in your head, though, is the adding. You just have to do the adding in your head. I know it was only day one that I did synthetic division, but you did it last year, so it should have been recalled. So let me show you the first one. For dividing by x plus 3, first of all, what do I synthetically divide by? Everyone? 3, 2, 1, go. -3. So -3 goes here. And then this is what I did. I actually did the first one and I wrote the answer, but watch and listen. Watch and listen. So I'm going to synthetically divide by -3. And I used to do this because we used to do a lot more with synthetic division. We used to graph using synthetic division because of our property today, the remainder theorem, which we'll get to in a minute. But then what's the first thing you do in synthetic division? What do you do with that 2? You what? What do you do with the 2? You bring it down. Then what's the next thing you do with the -3 and the 2? What do? Multiply. I hope I didn't make any mistakes. I did this right before you guys walked in. You multiply, that's -6. Hold. Then what do you do with -6 and 7? You what? Add them. So this is a way of just not writing the multiply part, holding some math in your head. And then what you can do is kind of synthetically divide with a few numbers within the same charts or whatever, same synthetic division thing. I think last year I showed this to my students doing this way, but whatever. If not, no big deal. Then -3 times 1 is -3. Hold. -3 plus -4, -7. -3 times -7, 21. Hold. 21 plus -27 is -6. Then lo and behold, -3 times -6 is 18. 18 plus -8, or 18 plus -18 is 0. So then if I had to write this as a depressed polynomial, as a quotient plus remainder divided by divisor, I tag on x cubed, x squared, x constant, and then remainder over the divisor. Don't ever write that final answer in there. I was just being lazy. Don't do this on a test. But I didn't want to have to write this over and over again. All right, so the next one. Here's what we get. This is for making an extrapolation here. Boom. Dang it. And then, I don't know, oh, good thing. Okay, and then I think I lost my 0 there. All right, I'll write that with my mouse. Looks like a square 0, a roadblock 0. Anyway, so bring down the 2. -2 times 2 is -4, plus 7 is 3. -2 times 3 is -6, plus -4 is -10. -20, or +20 plus -27, -7, so on and so forth. All right? Just doing fast. Expect you to know what's going on here. Got to move on. All right? And then all the other ones, you know, I got the numbers now. It's really about our extrapolation up to the right here with what I'm going to do on the graphing calculator. All right? So I also don't want to do a lot of work of input, say it. That's what this says. Now, given this function, evaluate. This is not a coincidence. P of -3, P of -2, P of -1, and P of 2, which means plug them in, evaluate, and get an output value. I'm going to do that with the graphing calculator. And then hopefully I can see this stuff here. Move this over. I get nervous when I do this because then there's some crazy stat thing that comes up. Okay, so what we have to do first is plug in our polynomial. So 2x. If you got no graphing calculator, you're severely and totally behind. All right? Getting to get these non-doers kind of showing their true colors here as we go, and it's causing some problems. See what I just went through there? I hate that. The cubing and the forthing, when I do the caret button, it's hard to get out of that exponent. I almost made a mistake there in typing. 4x squared. This is why I always hit the squared button. The squared button gets me out of the exponent. Minus 27x. Can't say I'm going too fast, or you can say it. She'd be a liar. Okay, a liar. You should be ahead of me here. So all I did is typed in y1. I'm double checking that it didn't make any mistakes. That polynomial. And then I'm going to hit zoom standard, even though when I deleted my memory, we already had it. It would be from 10 to negative 10 on both x and y axis. Now, I don't know if I've showed you this before. I know two of the classes I did, or one of the two classes I did, A, B, or B, C. We're now going to calculate input, say it. We're going to calculate values on our calculator. So it's value. We're going to input -3 and see what we get. So value, hit 1 or enter, and then that's what it's waiting for. Who do you want me to calculate? Hit the negative button. The negative button's down here, okay? So you don't see me over here. I should get this so that you can see the screen perfectly, okay? Maybe a little bit better. But the negative button. But anyway, press enter. Hey, look at our look at -3 comma 0. Look at the remainder. You see that? Okay. Hey, let's do another one. Let's see what -2, -1, and 2 ended up becoming. Boom. So second, calculate value. This is way better than doing this by hand. -2, enter. Didn't it say -4? Did it say -4? I hope so. And then -1. I didn't remember if it was -4 or not. Short-term memory loss. -1. Didn't we get a 0 there? Hey-oh, right? Okay. And then second, calculate, what was it? Value, was it 2? Was it 2? 2. Hey-oh, okay. So what you just saw was what's called the remainder theorem, all right? And then I do have to go back into writing here. And then I got to move the, hey, look at my shirt, by the way. Math is easy. Find x. It's right there. Go ahead, do that on a test and see what you get, right? Okay, anyway. These remainders equal input, say it, the outputs if I input those x values. All right, that's called the remainder theorem. So that's why we used to use like this format for a cubic or whatever, or even a quartic, that I would plug in -3 to +3, and that would be my chart of values. Input, output, then we graph those points and connect the dots, and you would see what a graph looked like. We used to do that because we used to be less graphing calculator, more hands-on. This is like, I was actually, when you guys walked in, I was looking at my students of 2010 because I just talked to an ex-student that teaches here, and I was trying to find her in my seating chart. I forgot when she was actually graduated though, so I couldn't find her quite yet. But anyway, she had to do that by hand and graph quadratics and cubics and quartics like that using the remainder theorem. Okay, so if a polynomial is divided by x minus k, the remainder is whatever f of k equals. That's input-output language. So if I have to evaluate f of -2, I could literally just plug it in if I wanted. Or, now this is where it gets tricky. What do I synthetically divide by? Do you think it's -2 or 2? What's the answer to that? And the answer is -2. This is not a factor. This is actually the number I'm inserting into the polynomial. So this is actually what I'm going to synthetically divide by. Now I'm going to go to the old school yesterday doing the synthetic division. And then this is what you're supposed to know about this then. 3, and then 2 times -3 is -6, and that's 2. 2 times -2 is -4, and that's 1. These were what I was holding in my head in that other way of doing it, right? I was just doing the math in my head. And -2 times 1 is -2, -9. So what would you say at the end? F of -2 should equal -9. If I plugged them in, that's what I should get as an output value. That's what the remainder theorem says about what's this is why sometimes synthetic division, it actually is called synthetic substitution, which I'm surprised they don't have that up here. So let's write that down. Synthetic division works when the answer is a polynomial depressed. Synthetic substitution, it's called because it takes the place of substituting a number in for x into a polynomial. That's often why you hear that term as well. This is called synthetic substitution. All right, and then 1/3, don't have a conniption about 1/3. It's just a fraction. And notice I have 3 there, so it's probably going to work out nicely. 5 and -7. Bring down to 3. 1/3 of 3 is 1. Look at this. 1/3 of 9 is 3. Ah, no. 5 plus 3 is 8. 1/3 of 8 is 8/3. Oh, now we got that. You know what -7 is? It's -21/3. So would that be 13/3? Is that right? Is 13? Oh, sorry, wrong. Be -13/3, right? So f of -3 would be -13/3. That's what you should get. You probably get a decimal if I would have put this in the calculator and plug it in. Hopefully I didn't do any mistakes on the math there. I was kind of going fast. You better get the idea. Okay, next, better. Ooh, and then the factor theorem. We told you what factor theorem means. Something is a factor of something else if the remainder equals 0. We actually talked about this yesterday. In one of our problems where the remainder was 0, and I said, hey, that means this is a factor of that. All right? So use the factor theorem to identify which is a factor of, well, guess what? I'm going to do my other way of doing this. 2, 1, because this is just a yes or no question. -5 or 2, and I'm going to go ahead and put those numbers right here. But wait, I'm determining if x plus 2 is a factor. So what goes here? 2 or -2? What goes there? It's -2. This is when you put in a -2. The previous one I was replacing f of -2 with the remainder theorem. That means I use -2. This is not a factor. That was not on the previous question. When do we use opposite? That's what we got to understand. Bring down to 2, multiply, that's -4 plus 1, which is -3. So you just hold the addition in your head and do it in your head. -2 times -3 is 6. I'm getting excited. 6 plus -5 is 1. -2 times 1 is -2 plus 2 is 0. So what's the answer? X plus 2 is or is not a factor? Is. That's the idea. So that means we could, and that's what the future is. We're actually going to factor using synthetic division, then write polynomials in factored form. Okay, it's really a simple process. 1, 2, 1 times 2 is 2, 2 plus 1 is 3, 1 times 3, I'm getting excited again. 1 times 3 is 3, 3 plus -5 is -2. I could see the future. Anyone else see the future when you saw the previous steps there? Anyway, 1 times -2 is -2 plus 2 is 0. Guess what? X minus 1 is a factor because I got a remainder of 0. I could almost, what do we have here? 2x. Okay, so I actually, it's leaking into some later stuff there. All right, so then 2 times 2 is 4. 4 plus 1 is 5, making a movie here. So 2 times 5 is 10. 10 plus -5 is 5. I don't feel so good about this one. Couldn't you say no at this point, right? But anyway, 2 times 5 is 10. 10 plus not. Let's just put not. Let's get lazy with it. I really don't think any other of these could be, because I know what the last factor would kind of have to look like. -2 plus 1 is -1. It's because I know a lot about factoring. 1 plus -5 is -4. Don't feel good about this one. 4 plus 2 is 6. Not and not. But that's what your future holds. We're actually going to use synthetic division to depress a polynomial and then continue to factor it all the way through, or find zeros from it, so on and so on and so forth. Okay, kind of weird specific directions, but these are the last two. First one's easy. The second one's going to be a monster, right? And it's going to be a long division. Okay, so divide the polynomials. Great. Use synthetic division if you can. If the remainder is 0, this is where it gets strange. Use the results to write the polynomial in the numerator factored as the product of the binomial factor and the quotient polynomial. What? This in our old book was called polynomial form. Polynomial form. This was the form I warned you when we did the long division, saying I don't like this form. I like the fraction form. But anyway, Can I use synthetic division? Yes or no? Yes or no? Absolutely. You'd be a fool not to. What goes in the garage? 3 or -3? 3. And am I missing a term? Yes or no? Do I have to account for it? Yes or no? No, if you like wrong answers. Right? Okay, bring down the 1. It's Wednesday. Can you tell my attitude? Wait, this isn't a 0, is it? Okay, so let me start over. Bring down the 1, 3. I was expecting. Who else is coming in? It's Grand Central Station in here. Pass. Tyler? Yeah. Tyler? Where? Yeah, go. I guess he needs to go now. Oh, okay. All right. And then hi, I'm back. All right, and then 3 times -3 is -9. Is this a remainder of 0? Yes or no? No. Okay, so it did say in the directions. If the remainder is 0, then write it as a okay, so it's not. So I don't know what they were looking for here, the other two teachers. So I guess what we could do is say this. This is what it would have been in polynomial form. Divisor, I did show this the other day, times answer, which this is an x squared, 1x squared minus x. So I'm going against the directions here. And then what ends up happening is you add or subtract that remainder on the end there. I know you're not going to get that. They didn't tell us to do this. Just like having an old school remembrance of what how this works back in the day. All right. Really, what I like is 1x squared, x constant, and then -14 over x minus 3. When you write it like that is the best format when the remainder is not 0. So just forget about this. I don't get that. Who cares? All right. Just move on. And then you know what? I got to be a cowboy, baby. Because this is the worst. You ready? First of all, could I use synthetic division? No. Honestly, if that said like x squared minus 4, that factors to be x minus 2x plus 2.
Yeah.
So what you could do is factor synthetically with x minus 2, then take that depressed polynomial and synthetically divide by -2 for x plus 2. Did you hear what I just said there?
Mhm.
So that's a way. So honestly, you know what x equals when I set this equal to 0? Plus or minus, anyone? Plus or minus? Square root of 3 I, right? So you could synthetically divide by root 3i and negative root 3. Would you want to do that? Heck no. I almost said hell. Good thing I didn't. Poor kids can't hear these swear words. Cancel Mr. Samuelus. Holy crap. Raw? Yeah, yes. Oh my God. This is like a sadistic honors question. Am I missing a term? Am I missing a term? Should I? You should for spatial purposes. Oh my goodness. So I just told you I'm missing right after this period. So the other hour, actually, Mrs. Cooper does go through this one. And it's a lengthy video. She has this video separate. I don't think I'll be able to compose my video and be ready for fifth for them to watch mine. So, okay, here's what we focus on. You know what this tells me? How many steps are we going to have? An x squared, and I have to compare it to an x to the 6. How many steps do you think we're going to have? I see your fingers. 4, because I want to get it down to an x squared. So I'm 4 away right now. So I'm starting with an x to the 4th up there. Is that what's up there, by the way? X to the 4th, right? What times x squared equals x to the 6th? X to the 4th. And then good thing I did put that space there and then distribute. So this is 3. I'm sorry, what am I doing? This is x to the 6th. I saw that 3 there. And then 3x to the 4th goes here. What do I do next, everyone? Subtract. And I'm going to show that in different colors to distribute. If you don't know how to distribute, I can't help you. I'm done. There are certain things that are expected in here that you're supposed to know. If you don't know, you're supposed to work extra hard, right? And get it figured out. I think I need that x to the 3rd. Okay, then what's next? what times x to the second equals 4x to the fifth? That's an easy question. 4x to the third. Distribute. This is 4x to the fifth, exactly. And then 4 times 3 is 12x to the third. Sorry, 12x to the third. And then I'm going to change colors because then I'm going to show the subtraction. Why do we subtract? Division. Grade school. What I showed you when we took a number divided by another number. Okay, at this point, the Y's are done. You got to be there. This is why you got to do your homework every day. You honors kids. I'm going to have an honors kid not doing their homework. Makes no sense. Okay, this is where it gets crazy now. I'm going to start getting quite large here with our space. And then one more highlight. What times this x squared equals negative 3x to the 4? What's the answer? Negative 3x to the second is correct. Actually, it's a liar. There's 5 steps because we have to just consider the constant as well. So even I made that mistake. Negative 3x to the 4th just to cover a mistake I said earlier. And then this is negative 9x squared. We always got that little skippage. And then we're changing colors again to show the distribution of the negative. You're gone. You stay, though. That's for our next analysis. Oh, boy. Is that 28 negative? Just don't want to make a mistake there. So many possibilities for mistakes on this. You just got to be careful. It's not hard. I will never accept someone saying this is tough. It's not at all. You just got to be careful. Usually it's a negative that gets people. The distribution of a minus sign is usually what gets them. All right, we're going to do a fancy pen here. What times that equals negative 28x to the third? And the answer is negative 28x. I got to get rid of that line there. So it's negative 28x. This isn't going to look too much. This is a fancy marker. All right, and then that's negative 28x cubed. I should use this more often. It's fun. Oh, no. 30, 60, 8, 16, 24, 84? Is that negative 84x? What? How did that happen? That's a coincidence. And then when I hit this with a negative, you may not see much difference in that pen. I get negative 28x squared. This cancels. And then minus the 84 gets brought down. And then what's the last thing I got to write? What times x squared equals negative 28x squared? Another negative 28. And then lo and behold, I get negative 28x squared. And negative 28 times 3 is another negative 84. But let's go back to our original color. Subtract, and you get a remainder of 0. Hallelujah. Which is just a general word of praise, not tied to any religion whatsoever. Everyone just calm down out there. Okay? Now, I have a remainder of 0. So this question is good. Okay, this is what's called polynomial form. Divisor times quotients instead of that other way. So I wasn't even supposed to do that on the other one according to the directions. So that's what they're saying there. Okay, pretty much the video's over. How's everyone feel? Thumbs up? That's kind of a monster. That's about as bad as you're going to get for a long division question. Just being honest. Okay, and again, I was just satisfying that last sentence in the directions. All right? We like polynomial form. We like fractional form is what's this called. Where is that? That one right there where we did the bell work there, when I kind of stuck the answer there. But anywho, let's call it a day. Oh, Wednesdays. My second favorite time in the week is 2:48 on Wednesdays. You know what my first time in the week is? 2:45.